Hello children, welcome back to my channel. So this is the chapter number 1, force exercise 1. So that the first question is, state the condition when on applying a force a body has translation motion and one more is rotational motion. As we know that when a force is applied on a rigid body means which is unable to bend. So when a force is applied on a rigid body, there will be two kinds of a motion. One is translation motion and another is rotational motion. To cause the translation motion, the body must be free to move. Whereas in the rotational motion, the body is pivoted at point. Pivoted at point means which is fixed at place, which is not able to move freely. So in the translation motion, the body is free to move, whereas in case of rotational motion, the body is pivoted at a point. We'll go to the next question. Define the moment of force and its state, its SI unit. So what its definition says, the moment of force or a torque is equal to the product of the magnitude of the force and the perpendicular distance of the line of action of the force from the axis of rotation. Okay, for this we'll take one example, then only it is easy to understand the definition. So here is the one rigid body which is pivoted at a point. The name is given for that O. And here is the external force is applying horizontally, and here one line of action of force is created. For that name he has given AP. So this is only magnitude of force which is in the definition, remember. Okay, and here is the pivoted point so that only this body rotates. So here is the axis of rotation happens. So axis of means here it will be an axis which is passing through this pivoted point, and here it creates one perpendicular distance between what, this line of action. 1 minute, I'll just change the color. Perpendicular distance between what, this line of action of force and this axis of rotation. So this distance only will take in the example, and it must be perpendicular distance. We cannot take any other distance like this. So it must be perpendicular distance. Now we'll go back to the definition. I think it's clear to you all. I'll just tell one more time. Here is the magnitude of a force between, this is the perpendicular distance of, this is only line of action of force and the axis of rotation or a pivoted point. Okay, now we'll go back to the definition. Okay, now the moment of force is equal to the product of means here we have to do multiplication in between what, multiplication between magnitude of the force, that external force, and the perpendicular distance of the line of the action of the force. How the line of action force is created by this force only from the axis of rotation. So that axis only the body starts to rotate. So this is the definition for this. So how comes, now you all know. And SI unit of the moment of force is Newton meter. For force unit is Newton, and still it is a distance for that meter. Next question, state whether the moment of force is scalar or a vector quantity. Since it shows a direction, so this is the vector quantity. Next question, state two factors affecting the turning effect of a force. It's very easy answer. Why? Because these both factors which is in the definition of the torque. Okay, the first factor on that the turning effect which is depend actually the magnitude of the force. So how much force applied on that the turning effect will be depend. So that is the first factor. The next one is the perpendicular distance of the line of the action of the force from the axis of rotation. So again the turning effect which is directly depend on this distance. So why it is depend on the distance we will understand in the next questions and all. So it is very easy to remember. Either you can remember this factor or that definition, you can write for both questions you can write the answers also. Fifth question, when does a body rotate State one way to change the direction of rotation of the body. Give a suitable example to explain your answer. So when does a body rotate? So when the external force is applied, then only the body starts to rotate through that pivoted point, as we know this already. The force applied on a body at a suitable point rotates the body about the axis passing through the pivoted point when only the body is pivoted up point. So in this they are telling the force is applied at a suitable point, and here is the pivoted point. What it means by suitable point? Suitable point means external force applying at a suitable point. It means there must be a maximum distance from the pivoted point. So if it is maximum distance, it's required a less force, but there will be more torque. So about that we can discuss in the next coming questions. Okay, now by changing, so by applying the force, the body starts to rotate. It's a clear now. So what is the next sentence says? State one way to change the direction of rotation of the body. Here it means when by changing the point of application of a force, the direction of rotation can be changed. Figure below shows the anti-clockwise and clockwise movement. So in the rotation, one will be anti-clockwise and another will be clockwise direction. Okay, if you are applying in this particular suitable point, or here if you are applying, it will start to rotate. And if you are applying in this direction, or here if you are applying a force, it will start to move in the clockwise direction. So there is a two type of direction. One is anti-clockwise direction, another one is clockwise direction. And one more question is what? Give a suitable example to explain your answer. So here is the figure given below shows the anti-clockwise and clockwise movement produced in a disc pivoted at its center. Here is a disc which is pivoted at a center. By changing the point of application of force F. Here is the force given by F from A to B. From here it is in this direction, they have given in this direction, here like this. Okay. Sixth question. Write the expression for the moment of force about a given axis. For that expression is force into perpendicular distance of force from the axis of rotation. So this is the expression for the moment of the force about a given axis. As you know that already what it means, force and force are a perpendicular distance of a force. Next question. What do you understand by the clockwise and anti-clockwise moment of force? When is it taken positive? If the effect on the body is turn it anti-clockwise, the moment of force is called the anti-clockwise moment, and it is taken as a positive sign for that. So if the body starts to rotate in anti-clockwise direction, that moment of force is called anti-clockwise moment, and for that sign is taken to be as a positive sign. Okay, and if the effect on the body is turns to clockwise, moment of force is called the clockwise moment, and for that negative sign for clockwise, negative sign for anti-clockwise, positive sign. So these both signs it will helps in the doing the numericals. Eighth question. State one way to reduce the moment of given axis of rotation. So what it means? How we can reduce the moment of axis of rotation? How we can reduce it? By decreasing the perpendicular distance from the axis of rotation, we can reduce the moment of given. Okay, as we know that already, perpendicular distance, here is a pivoted point and here is the force which is actually applied at a suitable point. Suitable point means almost it will be free end of that body. This is the distance. If you reduce this distance, just change the color. If you reduce this distance, means for example you take this much only. So here if I am applying a force, means obviously there will be decreasing in the moment of rotation, and if the distance is made a maximum, that time the rotation will be maximum. Remember here, as the distance gets reduced or decreased, there will be reduced in the moment of given axis of a rotation, and as the this distance get increasing, there will be more moment of the axis of rotation. I think it's clear to you all. Okay, ninth question, it is there only. State one way to obtain a greater moment of a force about a given axis of a rotation. So by increasing the distance, there will be greater moment of a force. I think it's clear to you all. Why is it easier to open the door by applying the force at the free end of it? So obviously I'll just roughly draw here. Here is the free end, I'll just name it as a P, and here is the hinges. Okay, means that is a fixed at a point. So here is the free end of the door. If here the force is applying, it will be easily rotate, and if you are applying force here, it takes greater force but there will be lesser rotation. If the forces is exactly applying on this hinges, means there will be no rotation. Why? Because here is the distance, you will get 0. Okay, so maximum the distance, the rotation will be easy. Okay, why is it easier to open the door by applying the force at a free end? So larger the perpendicular distance, lesser force is needed to turn the body. I think it's clear to you all. We'll go to the next question. The stone of hand floor grinder is provided with a handle near its rim. Give reason. Because by applying a small force at the handle, it can be rotated easily about the iron pivoted at its center. So hand grind floor will be, just draw roughly. Here will be the that handle which is almost near its rim, almost is free of the end, and here this is the pivoted point. Okay, so by applying a small force also here, it will start to rotate very easily. Next question, 12. It is easier to turn the steering wheel of a large diameter than that of the small diameter. Obviously, again, what is the give reason? Obviously, large diameter, there will be larger distance. Okay, from the center of rim. Whereas, so it is easier to turn the steering wheel of a larger diameter than the smaller diameter. Next question. A spanner has a long handle. Why? Again, its spanner produces a larger turning effect, because there will be a larger distance, means larger turning effect will be there. That's it. It's very simple. 14th question. A jack screw is provided with a long arm. Explain why. Again, it's very easy. A long arm of a jack screw is used to lift a heavy load like a vehicles, will help to apply a less effort, which is it must be required, required, okay, required to rotate it to rise or lower the jack. Hence the jack screw has a long arm.